Hello and welcome to Technical Utkranti, and today we'll be seeing the M coloring problem. So let's have a look at the thought for the day. Alright, so this is the 10th video in recursion and this is the ninth question that we are going to solve. So let's get started and look at the question. You are given an undirected graph in the form of adjacency matrix. What is adjacency matrix? We'll see in shortly. There are n nodes in it and you are given m colors. Can you color all the nodes of the graph such that no adjacent nodes have the same color? Let's go to the whiteboard. Firstly, understand what is adjacency matrix. If you are given a graph like this, so you have three nodes 0, 1, 2, and the graph is like this. We see that 0 is connected with 1 is connected with 0 and 2 is connected with 1. So adjacency matrix basically is an n cross n matrix where each row number represents the node, each column number represents the node. Then if you see this particular row, you will see that node 0 is 1 only for column 1, which means that node 0 is connected with 1 as shown over here. Then node 1 is connected with 0 and 2. Correspondingly, these entries are 1 and this is 0, right? And node 2 is just connected with 1. So this entry is 1 and these are zeros. So with adjacency matrix, we can get to know that for a particular node, what all are the adjacent nodes for that particular node, right? So this information is going to be useful. Okay, let's move on and understand the code further. What we need to verify? We need to verify that whatever color we give to a particular node, its adjacent node should not have the same color. So since we are talking about color of nodes, it is better to have a data structure that shows which node is colored in what color. I'll create this data structure, this list basically, which would be of the length of number of nodes and initialized to all zeros, representing all nodes are not colored or are uncolored. All right. Now, how many colors we have? We have two. So one color will represent by one and another color will represent by two. All right. Now we'll try with color one on node 0. So we have node 0 and I'll try color 1 on it. How can I say that this color is okay for this particular node? What I need to do is, for this node, I need to find all the adjacent nodes. I'll go to the adjacency matrix and I'll find that the adjacent nodes for node 0 is just node 1. Then I'll see what is the color of this. So I'll refer to this data structure index 1 and I'll see that node 1 is uncolored. So basically I can give color 1 to node 0. Alright. Once I assign color, I need to update this particular data structure. So for node 0, color is 1. Alright. Then I go to node 1. I find its adjacent nodes. So its adjacent nodes are 0 and 2. 0 and 2. Okay. So for node 1 also I'm trying color 1 first of all. And I'll see, okay, what is the color of node 0? It is 1, which means that I cannot try this color. So I'll try color 2. Alright. So what is the color of node 0? It is 1. What is the color of node 2? It is 0, which means color 2 for node 1 is fine. So I can assign color 2 to node 1, and here I'll update it. Then I'll go to node 3, or basically node number 2. What are its adjacent nodes? Just node 1. So adjacent nodes are just one, and I'll be trying color 1 on it. All right, to begin with. So node 1, which is the adjacent node of node 2, has the color of 2, which is different from color 1. So I can assign color 1 to node 2 and update it. Right. So this is possible. That's what question asks. Can you color? Can you color this particular graph with these number of colors in a way that adjacent nodes are not of the same color? So once you can obtain this, you can return true. Let's have a look at the code. Okay. So what I am doing, I have created this color, and then I am calling this try color recursive function, which holds this data structure, the adjacency matrix, and the number of colors. All right. So I have this function over here. What I do, I'll take the first. I'll see if it is colored or not. If it is uncolored, then only I'll try coloring it. All right. And if it is colored, I'll move to the next. All right. Fine. Then I will see that I will iterate on all the colors. So I'll see for all the colors if a particular color is valid, if a particular color is valid for this node or not. Basically, let's assume that this will tell me that whether you can color this node with this color or not. If I can color, I'll color it. All right. Then I'll go for a recursive call again to check for the other nodes. So basically, with this particular choice of color for this node, if I can color all the nodes subsequent to this node, then I will return true. And similarly, this will also return true, and the recursion will proceed towards closure. In case with this choice of color for this node, for the subsequent nodes, I am not able to fill any uncolored node. If I am not able to fill with any color, then I'll return false, and which would mean that this choice of color for this node was not right. So I will set this color, set the node of this color back to uncolored, and try to color this node with different colors. I hope you understood this recursion properly. Now let's understand is valid. So in the is valid function, we are simply finding all the adjacent nodes of the node that we are trying to color. Then I'll iterate on all the adjacent nodes and see that if the color of that node is equal to the color that I am trying, then I'll return false. Otherwise, I'll return. So I hope this particular code explanation was clear to you. Let's submit and see if we can submit. Yes, we can submit it. So I hope you liked the question, the approach, and the solution. If you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.